Let's take a look at this example. This time we're supposed to find, let me write this down, find voltage VA, okay, voltage at this point. We're supposed to find voltage VB, okay, voltage at this point. We're supposed to find voltage VAB. We're supposed to find current I1, okay, current which goes through resistor R1, so this is current I1. We have to find current I5, okay, current which goes through resistor R5, so have I5. We're supposed to find power at resistor 4, okay, I call this power P3. Okay, and this is basically it. So how I'm supposed to solve this problem? I'm going to solve this problem by finding first the total resistance. In order to find the total resistance, I'm going to find first the equivalent resistance for these two resistors, okay? So we have R45 is equal, because I have just two resistors, I'm going to use product over the sum. R4 times R5 over R4 plus R5. And now I'm supposed to plug in the values, so I have 3.3 kilo ohms, okay, times 4.2 kilo ohms over 3.3 kilo plus 4.2 kilo. Okay, this is equal. Now I'm going to use the calculator like always. Okay, let me set up this calculator to engineering notation. Okay, so I have 3.3 exponents 3 because I have 3.3k times 4.2 exponent 3 equals, divide by open parenthesis 3.3 exponent 3 plus 4.2 exponent 3 close parenthesis. This is equal 1.84 kilo ohms. 1.84 kilo ohms. This is the equivalent resistance for these two resistors. Now we can redraw the circuit. So the circuit right now is going to look like this. I have simply my R1, and this is going to be my resistor R45. This is my ground. Okay, this is my point VB, and I have over here R2, and I have R3, and I have voltage source over here. This is my voltage source, and this is of course my point VA. Okay, so this is basically what we got so far. Next, what I'm going to do, I'm going to simply add these two resistances because these two resistors are in series, as you can see, right? So I can find the equivalent resistance for these three resistors. So I'm going to have resistance R145 is equal R1 plus R45, where R1 is equal 1 kilo ohm plus R45, which is equal 1.84 kilo ohms, and this is equal 2.84 kilo ohms. Okay, so this is the equivalent resistance for these two resistors. Now I can redraw the circuit one more time, and I'm going to have circuit looking like this. This is my resistor R145, and after that I have resistor R2, and I have resistor R3. Okay, and this is my voltage source. Okay, so now we can see that these two resistors are in parallel. So I can find the resistance R 1, 2, 4, 5, means I have to find the equivalent resistance for these two resistors. So I have that in parallel and I have two resistors, that's why I'm going to use the product over the sum. So I have R 1, 4, 5 times R2 over R1, 4, 5 plus R2. Plug in the values. So we have R145 is equal 2.84K, 2.84K times R2. R2 is equal 2.2K, 2.2K, okay, over 2.84K plus 2.2K. This is equal, so R1, 2, 4, 5 is equal, let's use the calculator again, and we have 2.84 exponent 3 times 2.2 exponent 3 is equal, divided by open parenthesis 2.84 exponent 3 plus 2.2 exponent 3 close parenthesis equals, this is equal 1.24 kilo ohms. Okay, so this is the total resistance of these two resistors together. Okay, now I was supposed to find entire total resistance. Okay, so we can redraw the circuit again, and this time I'm going to have resistor R1, 2, 4, 5, and this is going to be my resistor R3, and this is my voltage source. So now you can see that these two resistors are in series. So if you want to find entire total resistance is equal R1, 2, 4, 5 plus R3, because these two resistors are in series this time. So I have 1.24K, 1.24 kilo ohms plus R3, which is equal 5.2. Okay, this is my R3, 5.2 kilo ohms. So 5.2 kilo ohms. Okay, so I have R total. R total is equal 6.44 kilo ohms. Okay, so this is my total resistance. For those of you who do not see that, you can use the calculator. So I have 1.24 exponents 3 plus 5.2 exponents 3 is equal 6.44 kilo ohms. Okay, I found the total resistance, and of course you can redraw the circuit if you want to. So your circuit right now is going to look like this. This is going to be your total resistance, and this is the voltage source. In other words, the original circuit I can replace by simply one resistor, which has value 6.44 kilo ohms. This is my voltage source. Next, when I have total resistance, I can find the total current. Total current, I total, is equal voltage source over R total. Okay, because I have voltage source and I have total resistance, I have just one resistor at this moment, so I can find very easy total current. So voltage source is given is equal 15 volts. Okay, we have 15 volts given. 15 volts. divided by total resistance, we have 6.44 kilo ohms, and this is equal 15 divided by 6.44 exponents 3. This is equal 2.33 milliamps. 2.33 milliamps. Okay, so this is my total current. So we have I total. You're supposed to realize that the total current is the current which will flow through the resistor R3. So we can say that I total is equal also I3. Okay, the current which goes through resistor R3. One more time, the total current goes through the resistor R3, and this is equal again 2.33 milliamps. Next, the problem is asking me to find the current which goes through resistor 1. Okay, I'm supposed to find this current. So in order to find this current, what I'm going to do, I'm going to look at this diagram. Okay, I know that this current is my total current, I total, right? I total is going to split into two currents. So if I have parallel circuit, I can use current divider rule. Okay, this is my total current, and I want to find the current which goes through the resistor R1. Okay, and this is basically my resistor R1. So if I'm going to find the current which goes through this resistor, this is going to be the same current. Okay, so what I'm going to do right now, I'm going to use the current divider rule. So I'm going to simply write that I1 is going to be equal, look at this diagram, this one. I1 is equal I total, or we can say I3, this is the same thing, I total times equivalent resistance of these two resistors. This is current divider rule. Okay, so this is going to be R1, 2, 4, 5 over R1, 4, 5. R1, 4, 5. Okay, and this is equal. I total, we found this is equal 2.33 milliamps. So I have 2.33 milliamps times R1, 2, 4, 5, we found this is equal 1.24 kilo over R1, 4, 5. R1, 4, 5 is equal 2.84 K. 2.84 K. This is equal 2.33 exponent 3 negative times open parenthesis 1.24 exponent 3 divided by 2.84 exponent 3 close parenthesis. This is equal 1.01, we can say 1.02 milliamps. Okay, so this is the current which will flow through the resistor R1. Okay, so we found I1. Next, we're supposed to find the current which goes through the resistor R5. Okay, again, we are going to use the current divider rule because I know these two values of resistors and I know this current. So I can use the current divider rule and solve this current by using that law. So I can say that I5, okay, I5 is equal I1 times the equivalent resistance for these two resistors. So I have R45, R45 divided by, and because I'm looking for the current at resistor R5, I have to divide by R5. So this is equal, I1 we found is equal 1.02 milliamps times R45 we found is equal 1.84 kilo ohms, 1.84 kilo ohms over R5, which is equal 4.2 kilo ohms, 4.2 kilo ohms, and this is equal, okay, we're going to use the calculator. We have 1.02 exponent 3 negative times open parenthesis, and I have 1.84 exponent 3 divided by 4.2 exponent 3 close parenthesis. This is equal 446.85 microamps. Microamps because I have over here -6. Right? So we found I5, we found I1. We can find right now P3, okay? Power at resistor, in this case, 4. Resistor 4, because I have over here P3. So it means I have to find the power at this resistor. So in order to find the power at this resistor, I'm supposed to have voltage across this resistor, or I can find the current across this resistor and use the formula for current and resistance to find the power at this resistor. So because I know the current which goes through this resistor and I know the current which goes through this resistor, I mean the resistor R1, I know this current, so this current minus this current will give me this current. So let's find I4 first. I4 is equal I1 minus I5. Okay, so I1 we found is equal 1.02 milliamps minus I5, which is equal 446.85 microamps, and this is equal, okay, we have 1.02 exponent 3 negative. This is my current I1 minus 446.85 exponent 6 negative. This is equal 573.15 microamps. Okay, so this is the current. This is the current which goes through resistor R4. Okay, this is my resistor R4 over here. R4. So now if I have the current and I have resistance, I can find the power. So I can say P3 in this case. P3 is equal I4 to the second power times resistance R4. And this is equal 573.15 microamps to the second power times resistance R4, 3.3 kilo ohms. This is going to give me, let's check, 573.15 exponent 6 negative to the second power times 3.3 exponent 3. This is equal 1.08. I get 1.08 milliwatts. 1.08 milliwatts. Okay, so this is the power at resistor 4. So far we found current I1, we found I5, we found power P3. Next we're supposed to find the voltage at this point, VA. Okay, voltage at this point is the voltage between this point and ground. So you can see that this is the voltage across voltage source. So I can say that VA is equal what? Voltage source. So I'm going to write that VA is equal voltage source, and this is equal 15 volts. This is my VA. Next, I supposed to find voltage VB. Voltage VB is the voltage between this point and ground. So voltage VB is the voltage across these two resistors. Okay, so in order to find this voltage, I'm going to multiply, let's say, current I5 by R5, and I'm going to obtain this voltage. Okay, so I can say that VB is equal to voltage across resistor 4, or this is also equal to the voltage across resistor 5. I'm going to use the current 5 and R5. So I5 times R5 is going to give me VB. I5 is equal 446.85 microamps times R5, which is equal 4.2 kilo ohms. So this is equal 446.85 exponent 6 negative times 4.2 exponent 3. This is equal 1.87 volts. This is voltage B, VB. Next, I'm supposed to find voltage VAB. VAB is the difference of these two voltages, so VA minus VB. And this is equal, VA is equal 15 volts minus VB, which is equal 1.87 volts. So I have 15 minus 1.87 volts. This is equal 13.13. Save 13.13 volts. Okay, so this is my voltage VAB. We're supposed to find also power P2. Okay, I forget about it, so we have to find power P2, and let me show you how to do it over here. So P2, power at resistor R2, I'm going to simply find by finding the current which goes through resistor R2, and how we can find it. Because we know current which goes through resistor R3. We know current which goes through resistor R1, so the difference of these two currents will give me this current, because this current minus this current will give me this current. Okay, so in order to find P2, I'm supposed to find current I2. Okay, so let me write this down over here, so I can say this is going to be my I2. Okay, let's write this down over here. I2 is equal I3 minus I1, where I2 is equal I3. We've found, this is our I total, is equal 2.33 milliamps. 2.33 milliamps. I have 2.33 milliamps minus I1, and we found that I1 is equal 1.02 milliamps. So 1.02 milliamps. So I2 is equal 2.33 exponent 3 negative minus 1.02 exponent 3 negative is equal 1.31 milliamps. Okay, so if you want to find the power, P2 is equal I2 squared times R2. So if P2 is equal 1.31 milliamps to the second power times R2. R2 is equal to 2.2K. Use the calculator. So I have 1.31 exponent 3 negative square times 2.2 exponent 3 is equal 3.77 milliwatts. So now we can say that the problem is solved.